very important topic in the process industries, that is the control wall. As day before yesterday, I told that any process plan, industrial process plan, maximum maintenance is required on the output devices, means control wall. So control wall in industry is very very important, and maximum manpower, skill manpower is also required for control wall in the instrumentation. So I will give you brief about the control wall installations, then how, what are the accessories, and what type of maintenance required, so that you will get prepared when you will join the industry. So this is what today's objective we have set, to give you a brief idea about the control wall accessories, control wall applications, and a little bit about the maintenance. And then we'll furthermore we'll discuss about the innovative. Innovative means there are some aspects here. Control wall earlier were totally mechanical and operated on the pneumatic positioner. Now it is later on it is we started using means electronic positioner. Then we switched to the digital positioners. Now we have a technology with the wireless positioners. So a lot of innovation happened. But in the step by step, once you understood the concept or equipment or instrument accessories and their applications, then it will be easy to understand the further benefits of the technologies. So with this objective, let us start now. So I will go fast. This is again, I'm just refreshing you process loop, sensor, transmitter, controller means DCS, and control element means control wall. Is a major equipment associated with the I2P converter. You are aware about the I2P converter, I know. uh, n- Current to pneumatic converter. The output of the DCS coming in the current form, 4 to 20 milliampere is the range, and that current signal, electrical signal, has to be converted into the pneumatic signal, means air signal, that is in the range of 3 to 15 psi. So because control operates on the air supply, so that is the what it is the required. So control element means I2P and control wall. So see here again, this is the control wall, and I told I2P is on top of. In it, it is not possible to every time you install the I2P on the control wall. Normally, it is away because it requires also maintenance. But here in the picture for demonstration purpose, it is shown on the top of this. So you see this control wall in the line. This is the pipeline where you can see the orifice plate transmitters, and this is the control wall controlling the flow of the gas or liquid, whatever in this process line. Just here the basically control wall how it looks like. That is in the picture is showing the uh,
Hello,
parts.
sir.
Huh? Yes. Hello. Hello.
Sir, have you
Hello.
shared the PPTs?
Hello.
Have you shared the PPTs?
Yeah. Yeah. Huh. I will share. Huh. So I'm going fast or what? Hello.
Uh, yes, sir.
Are
PPTs.
you audible? Are you understanding what I my noise and my what
Yes, 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 yes. But
slides
whether
are
you have
visible?
shared the PPTs or not?
Yeah, yeah, we will share this PPT. Uh,
Okay.
Slides are very, I think, visible to you, understandable you or not. You can give me feedback accordingly. I can adjust in the next session. There's no issue.
Okay, okay, okay.
It is audible and visible, no?
Yes, you are visible, but slides are not visible.
Oh, ho, ho.
Slides.
The you can see the picture.
Yes, you are visible only. Slides are not visible.
Oh, ho, ho. Just why this is just madam. Uh, I will restart again.
Yes, yes, yes. You can restart
So
it.
why actually this should not happen like that? Huh?
इथे प्रेझेंट पाहिजे
Hello, hello, hello.
Hello, sir.
Uh,
Hello.
Now visible or not?
No, no, it is not visible.
But actually, this slide, no, no slide pictures.
No, you are not shared, sir. I think
Oh,
you have to
but
share the slides.
I shared it. Entire screen I shared.
Okay.
See here, entire screen share, and then I started my presentation. Is
Yes,
it
now
visible?
it is visible, sir. Make it full screen.
Okay, good.
Okay, okay.
So sorry if I had
No,
made
no,
a
sir. It's
mistake.
okay.
That was not clicked the share only. Huh?
Yes, yes, yes.
Sorry. Huh? So I was talking about the control wall.
Huh.
This is the loop. Day before yesterday, I have gone through this loop, but this is the control wall where I2P and control wall is shown on the pipeline. And I am showing this picture where you can see here control wall. Parts. You can see the control wall somewhat. This picture is lightly blurred, but this is the body portion of this, and this is shining as stainless steel is the uh, plug, and above below that is the seat. Then stem is there. This is the stem. This is the positioner, pneumatic positioner. Then you can see this diaphragm is here. This is the cut portion here, actually diaphragm, and this is a spring. So spring, diaphragm, stem, plug, seat, globe body. These are the major parts of the this positioner are the major parts of the control wall in the industry. So this is the control walls shown in the DCS. Many control walls are there, and transmitters. I'm skipping this. I'm showing the actual industrial plant control wall, how it is looks like. See, this is the one of the plant picture. Oh, sorry. The DCS graphic is also showing for that particular section where you can have the actual real-time control wall. What position control wall is, what percentage opening or closing it is shown on this graphics. This is the transmitters with the faceplate on the DCS side. Similarly, you can see here the control wall, because today we are discussing control wall. So you see this is the control wall. It is under new in the new project in the installation phase, because it is in the line there is a more than 400-degree temperature, so insulation is required. So before insulation, you can see here the flanges, wall body. This picture is clear now, madam? Hello. Okay. Then as I told, wall positioner, stem, diaphragm. So this is the what control wall
Yes,
looks
sir.
like. Yeah, yeah.
Um,
So my point is that when you see the actual control when visiting the site, it is
slides.
entirely
Okay.
covered. I will
It
show
will
the
looks
another
like
picture.
this. Correct, correct, correct. Okay.
uh, so you see here, before insulation of the line, because the temperature is very high, so has to be insulated. You see the control wall how it looks like. As I told, this is the direction of the flow, flanges, wall body. Inside that, plug and seat is there, which is not visible. Therefore I shown earlier slide cut portion where you can see the plug and seat, but there are some few slides more where you can get idea about the plug and seat. So plug and seat portions are here because they are the actual controlling the media, gas or fluid. So inside that you can say stem is there, positioner is there, and above that diaphragm, spring. So all these accessories are there. This positioner is a digital positioner, a hard positioner. So you will get here display how much percentage wall is open. However, in the pneumatic positioner, it's a mechanical one, so you will get an indicator there, uh, where you can see the actual position of the wall at what percentage inside it. But nowadays the technology is very very uh, we can say user friendly and useful to get the real value of the control wall, real fault of the control wall. We'll discuss later on that aspects. So This is what I was talking. How plug? Do you see this plug? Below the above the plug is a stem. This is a stem, and this link is there attached to the positioner. This is the positioner back portion, rear portion of the positioner. So you see this link. This is a mechanical link. So accordingly, like force balance system, using that the signal is generated, and that pneumatic signal is operating the wall through this air. So as I told, this positioner is a digital hard positioner. He is showing 31% wall is presently open on the site. Means if you see the earlier slide here, uh, this slide you can see positioner is shown here, and the display was not visible, therefore made it clear. But it is a 31%. It is showing the wall is open in the field indications. However, same indication goes to the control room on the DCS graphics also. So you can see here this screenshot of a graphics on the DCS workstation in the control room. So 31.4. However, you can see here is the percentage here, 33 something percentage is showing here on this side. This wall graphics. So this is a site. Again, these pictures are there. I was explaining the uh, control wall. So I'm skipping few slides here, which are not required now. Hmm. What is a control wall? So it is a power operated device which changes the fluid flow rate in a process control system. This flow rate changing is the main objective of this wall. It consists of a wall connected to an actuator. I have shown the actuator that is capable of changing the position of the closure membrane in the wall in response to the signal from the control system. Means what is here mentioned that control system send the 4 to 20 milliampere signal, control signal, which then converted through I2P 3 to 15 psi, and that signal is uh, just minute, madam, just minute, just minute. हा, मी बघतो जरा, मी अर्ध्या तासात बघून अपडेट देतो, राईट. हा, ओके. ठीक आहे, स्कोप म्हणजे मी बघतो. ठीक आहे. मिसिंग असेल तर आय विल अपडेट, राईट. ठीक, ठीक, ठीक. ओके, 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 ओके. Sorry for interruption. So control wall as per IEC. IEC is a standard body. They have standards. This I will explain here later on the standards, but actual definition in the standards, IEC standards: a power operated device forming a final element in an industrial process control system. It consists of a body subassembly containing internal means of changing the flow rate. So we have see whatever I have explained you on the picture, the same is in the text format. It is defined in the standard. So again, I'm repeating, in the control wall, globe body, inside that seat, plug, stem, then diaphragm, uh, then spring, and linking media which is connected to the positioner. So these are the major parts. Out of that, wall maintenance requires always with a plug and sit, because it which are always in the direct contact with the industrial hazardous high pressure high temperature gas fluids. So there lot of maintenance is needed, and the wall start passing means leaking, and they always we have to remove the from the wall from the line for the maintenance. So control wall, again definition is there, is a part of automation. So this is what I have explained you. So control walls used for fluids are a linear characteristics, as well as walls with a rotating closure membrane, such as butterfly wall and rotary plug walls. The control used in the processing plants are mostly linear walls. Maximum, you can say 80% walls are linear. So there are other standards like IEC and DIN is a German standards also there. So you can see different types of wall, globe walls. It's a globe body. So that is a globe walls. So here in this cut portion, you can see here in and liquid in or gas in, gas out. So here you can see the seat, plug, stem, then the springs and diaphragm here. Spring is here, and this is the positioner which is in cut portion. This is a positioner part, positioner electronics or mechanical assemblies here. So butterfly walls. Normally there are different types of slurries and type of material is there. So normal plug seat walls will get choked. So it is like a rotating plug walls or butterfly walls are used for that applications. So direction of flow is mentioned. The picture you see here, as I told you, see this is the seat portion, shining stainless steel body, and above that it is a plug. This is a plug portion. So what happened based on the uh, control input, the plug get lifted, and the gas or liquid, the gap forms between this plug and seat, and proportional gap forms, and that flow that is a controlled fluid goes out. So this portion is very very important, as I told, very sensitive, and getting damaged frequently due to choking, due to hazardous liquids. So this is what I have shown. So as I told, there are German standards are always with the number DIN, and IEC, as I told, this is a European standards. So when these are some theories related to the control walls. So I'm skipping that part which is related to design of the wall. Uh, but basically, it is based on the Bernoulli's equation. You are aware of Bernoulli's theorem. I have this. In this slide, you can see the specification sheet when we have to purchase or install the wall in the line. So the flow rate means either is the liquid has steam high vapor, that you have to mention, because there are different types of materials and different types of uh, mm, calculations are involved because of process, handling the process of the wall. Flow rate, प्रोसेस में आपको क्या फ्लो रेट चाहिए, दैट यू हैव टू मिनिमम मैक्सिमम इनपुट प्रेशर लाइन में कितना प्रेशर है, इनपुट साइड आउटपुट एक्सपेक्टेड, सो दैट टेम्परेचर. So all this data is required for sizing of the control wall. Based on that, the wall is properly sized. Otherwise, your flow will not be get controlled properly, or wall will either we can say uh, damage, or like a hammering, like vibrating, like that type of a phenomena happens. So most of the wall as we were discussing that the linear category, this linear characteristics, you can this side equal, this side linear. Equal percentage often logarithmic. This is a linear. Linear walls, normally you can see the linear character results in the change in the flow coefficient being directly proportional to the change in wall travel. Means wall travel means the stem and plug travel. Wall travel, stem, and it is plug is attached to the stem, and stem is operating based on the control signal. So it is a directly. However, equal percent with equal percentage characteristics, equal increments of wall travel produce equal percentage change in the existing flow coefficient. So these are the various characteristics, quick opening, and depend on your process requirement. How normally why I say like industrial plants, your uh, flow rates and all has to be not uh, means certain stage you require more flow, then no, low flow not required, it is a smooth flowing, so it is a linear is a preferable. But these are the types: linear, equal percent, quick opening. And these linear, when we say, then that is linked to the shape of the plug and seat. It's design of the plug and seat is related to that characteristics. So in the graphics you can see this is a linear graph. If you see the percentage of a rated travel and percentage of flow coefficient, so this character is the preferred. I told 80 to 90% also in the industry, process industry, is a linear. This is a link actually, this I'm skipping. So for sizing of the control wall, there are theory experiment, a lot of experiments are done. But as I told, Bernoulli's equation is the main basic for this design. So you see, this is the input side flow, then goes inside, then going out like this. So this way obstacle forms, and you see the pressure drop. Input side high, then drops at this point, then you will get always a differential pressure here. So suppose P1 is this and P2 is this, so dP will be always there, this much. This is the next slide, it is shown actually. So Bernoulli's equation is the theory. So I'm just skipping some mathematical calculation, but here you can see uh, control sizing means in the GPM is equal to CV is under root of delta P, means about G1. So delta P, as I told, differential in the pressure due to the obstacle. So that is this. So control valve sizing, the number of US gallons of water at 60 degree Fahrenheit, which will pass per minute through given flow restriction with a pressure drop of 1 psi. This is the CV of the control valve. So this is the guideline while selecting the uh, this is unit as I for sizing the control valves. So this is the what we can control: sizing, flow, then drop, and this is a vena contracta. So this is related to the this we can say differential pressure happens, and where you can measure it, that is the vena contracta. Uh, Normally orifice plate we discuss it. So these are the, you see, a high pressure drop plugs are shown here. So you see the plugs various size, as I told, shapes defines the characteristics: linear, equal percentage, and quick opening. Linear, quick open, V port, reduce capacity like this. So this is a very important, and we here a lot of maintenance is required. So always it has to shine. Mirror shining is required at this point. Then like three-way walls are also there. You can see here three-way walls. This one, and this one. So the input is coming from this side, and output is this side like this. I'm skipping this, but only picture will take. So you see here spring, diaphragm top, stem, and this stem is connected below to the plug. So this is here mentioning the IEC that with the incompressible fluids, the equation do apply. Means you cannot gas application walls are different. That is you keep in mind, and liquid fluids uh, control walls are different with the different sizes. Hmm. So incompressible fluids, liquids, limited flow due to the vaporization in the fluids in the wall. Compressible fluids means the gases and vapors, limited or maximum flow in the wall. Mm. When measuring the upstream and downstream pressure for use in the sizing equation, the following applies. So while sizing in the uh, manufacturers, the wall manufacturers normally do this sizing. So they measure 2D, 6D, like as I told you, Vena contractor, where you are taking tapping. So that way they measures. So this is a general flow equation for knowledge. Flow rate is directly proportional to delta P. बाकी तो constants है. So flow rate is directly proportional to the differential pressure created due to the obstacle of the walls. So here, अरे क्या हुआ? Hmm. Okay, you can see this is a closed wall while this is a cut portion. Plug seat. The walls are always modular, so separate parts you can take it maintenance. So that way it is shown in the graphics. This animation is showing. So these are all parts are separate. This part I have explained, but you see types of plug shapes. अलग अलग shape में V port, sorry, parabolic, micro ceiling and characteristics. So अलग अलग type के walls है, but based on your equal percent linear on of that it is showing. Hmm. So this is a parabolic plug. This is a V port plug. Hmm. Hmm. See here, when I was talking maintenance, because you see here, wall is a this is a plug and sit, and then is lifting. While lifting, you can see this type of scratches happens, and because of the stuff, the this passing happens like this. Even wall is closed, you'll find leaking. So these scratches you have to remove in the maintenance. Cavitation damage plug and seats means the plug and seat portion is getting damaged due to the cavitation effect in the wall. Second maintenance is the insulation because you can see here uh, in the insulation means why important. You see here when stem and plug getting attached, so it is connected to directly fluid. So here the chances of leaking your gas or liquid is there. So the seal is very important. These are the seals. So packages for special, these are for industry special as per requirement of the industry. They design the manufacturer designs. So noise attenuation. Mm. So this part I explained pneumatic actuator. You see, this is a pneumatic one. Uh, there are a wide range of mounting की अलग अलग टाइप के walls है अलग अलग shape में है you can have as per your process line requirement 34 kg wall 20 kg wall 59 kg based on water levels. So control wall how to calibrate now you see here in this picture to calibrate the control wall in the workshop you are first connecting to through regulator then pressure gauge and use the control signal through this regulator and check whether wall is uh, closing properly fully opening fully closing through connecting to the hydraulic line here, and then they open entire wall where the fault is there. Suppose if the only it is related to the calibration of the positioner, so there they repair there itself, calibrate the positioner only. If they found after calibration of the positioner also the wall is passing, leaking, or not fully opening for a 15 psi pressure means maximum, then also then you have to completely remove this from the line and this. So there are you can see here control problems in the industry. Wall does not complete its strokes, means full stroke nahi aa raha hai. If you have maintained the 15 psi, it is not fully 100% open. So wall is unbalanced. That is a possible cause. With an air regulator, sorry, with an air regulator, house who says, and test the pressure gauge, set the wall at a 3 to 15 psi. Wall body and stem are dirty because they are in the industry environment. Disassemble and clean the walls. So wall does not complete stroke because of some foreign materials obstacle is there in between plug and seat. So that is the reason wall is not fully opening. Second cause is the wall does not start opening at 3 psi, but a bigger pressure means wall ko low 3 psi mein wall has to open, so it requires suppose 5 psi. That means the possible cause is the wall spring is improperly adjusted. So the you have seen the spring near the diaphragm. It has not properly adjusted. There are adjustments there to adjust the spring pressure. So reducing the spring pressure until the wall starts opening at the 3 psi. So adjust that through the spring tension using that nut provided for that adjusting. Wall is wide open but does not provide the required flow. He's not controlling. Control wall is improperly selected. So that here your selection is not proper. A wall with a greater diameter or capacity is needed. Wall does not respond to air pressure change of 3 to 15 psi. That means wall diaphragm is torn or worn out. So remove screws to the disassemble the plate and replace the diaphragm. Control wall start opening at 1 psi and not at 3 psi. Means at a lower below 3 psi. Even we have set for 3 is a minimum. The wall spring is improperly adjusted. So increase the spring pressure until wall starts opening at 3 psi. So here you can see the when you are in the field or in the maintenance, these types of problems happens with the control walls, and you have seen maintenance related problem or selection related problems or your cleaning related problems. So these are the maintenance regularly requires, and some critical walls uh, in the line, uh, when you have to replace means you have to stop the plants. So this is a very very critical device instrument in the process industry. If you are maintaining wall properly, the plant is running without means any trouble and with the rated capacity. What we can say. But if the wall is not properly maintained, it will give regular problems and plant has to trip or stops for 1 week or 2 weeks. For then normally other activities are also carried out during this. So control and positional relationship here. So you can see a DCS controller sends the 4 to 20 milliampere signal, and positioner gets that signal if it is the electronic positioner. Uh, then this positioner takes the input air supply 20 psi, and then this positioner generates the control proportional control signal 3 in the 3 to 15 psi to the wall assembly. And this is a linking position feedback. So this is the positioner part you see here, and this is a as I told, is a link to the stem, link to the stem. So in this line, this picture, you see this is the wall, this is the positioner, and you see this is the link here. You see this linkage. This is a linkage which create the control signal converted means transmitted in the stem for that. So there are various types of when I say intelligent control wall means a smart positioner walls or a digital positioner walls. That what normally terminology is used in the industry. Because earlier it was a pneumatic. Pneumatic means a totally mechanical positioner design. And in the digital positioners, as you know, PCB, microprocessor, other electronics are there, and partly there is a electromechanical devices also. So relays is there, electrical systems are there. So, but supply pressure always a 20 psi as per standard. Electrical signal from DCS 4 to 20 milliampere, and then output pressure also 3 to 15 psi goes to the control wall. Right. The advantage of these types of walls positioner is it gives a diagnostics where the problem is. Early diagnostic. Sorry. Hmm. 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 So this is what I was talking. Positioners with the microprocessor design or intelligent control, like this heart signal. So heart input coming to from the DCS. It is a process in the this positional electronics. Control signal in the air format is generated. This is what it is there. Mm. So field bus means a digital positioner wall. You see this digital field bus cable, and this is the positioner here. The advantage of field bus positioner over the pneumatic positioner is that it gives a full diagnostics when you are in the control room screen, control room dashboard, we can say, your or your maintenance workstation, we can say. So you need not to go to the field and check what is happening in the wall. Earlier you have pneumatic positioner, you have to go to the site and check the status every time. Every day morning routine checkup means wall you have to check whether walls are passing, walls are properly showing the indications or not. But now due to the digital, you need not to go to the field, and you directly from the control room you can calibrate the wall and certain data, certain calibration or range related, you can directly download on this positioner. So no need to replace the wall from the line for simple tasks. However, if your plug and seat is damaged, then you have to remove from this line and do that maintenance, because it is a damaged plug or seat. Somewhere you have to do lapping work. You have to make a, as I told, a mirror finish. Then only it will be tight shut off. Otherwise, it will start leaking. Mm. So these pictures I have already shown. Mm. Uh, then there are some other walls for safety or control requirement, safety walls, relief walls, or sometimes we call safety relief walls. So safety and relief walls are employed to protect the equipments like quench towers, tanks, piping, compressors against high pressures. Though you can see safety wall is an automatic device designed to permit the relief of the excess pressure of a fluid confined in the container. Suppose in the container you have designed for 70 kg maximum pressure. Moment it is near to that, automatically the valve will get operated and quickly open, and coming pressure will be released. Normally the safety and will be the vapor and gas like simple, that is how in a pressure cooker. You have seen the pressure cooker. Moment the pressure goes above, wall quickly opens, then come down. So the same thing happens here in the safety valve. So that is for vapor and gas. Relief valve is an automatic device to relieve the pressure acting because of the static pressure exerted by the fluid confined in the container. These valves are its opening is proportional to the incremental. So here there is no like venting. Normally safety valves means venting. Here the your fluids are because the relief valves are fluid, as I told, it is automatically controlled and put it your liquid back to your recycling or storage areas. Then safety and relief wall is a combination of above walls. The function of safety and relief wall is based on the equilibrium of two forces. So these are for special devices. So if you see the safety wall and relief wall design, the function of each safety wall component is पहला the lock nut है to adjust the pressure. At what pressure you have to set. Adjusting screws है, bonnet outside body, stem, bonnet nuts and stem retainer. So if you see the picture, we have here some picture. Oh, sorry. Mm, Oh, I will show you picture in another presentation. Uh, so these are like lock nut, bonnet. We have seen this lock nut like control wall also. Same thing is there. But if you see this wall, by function you have seen it. The operation is either quick or incremental, proportional. So the operating range of safety and or relief wall is determined by the spring force. So spring is very important. How much you are keeping the tension. The maximum adjustment point should be exceeded 10% of the discharge trip pressures. For instance, the wall has been designed for 300 psi. The maximum adjustment that can be set at 330 psi. So that is the maximum. 10% you can adjust the spring. A plate with the wall design data is on the body of the safety. Means there is a metallic plate where all technical specifications or range everything is uh, written. But nowadays the data is available in the digital form. So no issue, no need to go to the site and read that. This include discharge pressure and working pressure also. The process conditions and the fluid characteristics are taken into account to define the most convenient position adjusting rings. So I will show you the actual picture. Then I will explain you. Hmm. Hmm. So this I will close. No. This smart wall positioner. Mm, mm. So I explain you the intelligent or smart wall. These are the positioners you see various types of and various manufacturer, different manufacturer. Like you can see here, Fisher. You can see here, Samsung. Then this is some other make Mesolin, some Mesolin. Oh, sorry. Mm. So when we were talking about digital positioners, so field bus, foundation field bus is the digital signal is processed in this electronic CPU and then finally goes to output. Hmm. So smart wall positioners reputed make Emerson has a field view, wall link. Honeywell has SVI 3000. Siemens, these are the model numbers. Sipart, Smar has FY. Dresser has a wall. Samsung has a Samsung 3730. Like this, these are reputed manufacturers of the wall positioners. So as I told you, the control wall is a very, very critical and important for the process industry. So more the smartness in the wall, more the life of reliability of the wall is more. So benefits of the smart portfolio, you see the diagnostic features and benefits. Wall position versus control signals. One of the slides I explained the wall how is not properly operating with the control signal. So that wall position versus control signal. So indication of seat wear and pipeline obstruction. These are the indications will be shown to you. Historical recording also total how wall was operating, because earlier you don't have a history of the wall how was for last one day, 1 week, month, or more than that, how a wall was operating. So you cannot judge the reliability or life of the further more further life of the wall. So because of history and their past performance, you can have some idea to when to all repair or take to maintenance. So then total travel recording, stroking speed, wall, which part is faulty. So entire data is stored, and the characteristics is shown, and you will come to know the which area is the faulty in the wall. So this we have explained it in short. The small checklist. These are the different manufacturers and their features. What type of walls they are having. Like a SMAR has a or a analog 420 hard foundation pillars, profibus. So like this, it is there. Mm. Oh, sorry. Mm. So intelligent control wall system schematic diagram. If you see here more detail, as I told, I2P, then further electronics you can see the relays and all, and you see this wall is giving these commands. Intelligent control wall system, first of all, what does intelligent in a control wall system mean? There has been some confusion in the use of the terms smart and intelligent. Smart generally means that the device has a digital microprocessor that can talk to a host over a digital communication protocol and can handle simple tasks such as diagnostics and calibration. We have defined intelligent to include smart devices, but also to cover devices that can perform all three actions of a control loops: measurement, control, and process regulations. So further more features are added in the intelligent control system, because through some software algorithms, based on that it is possible to get measurement, control, and other related process regulations. These valves also should be able to monitor and process and bring it to a safe condition if there should be a failure or upset condition. Fail safe valve, that is called a fail safe. If something fails, the valve should stop or open. We generally have found that intelligent offers a significant benefit in three areas: performance, maintenance, and safety. Anyway, these my what is the takeaway? The digital walls are giving all these benefits uh, for the industry. That's all. Hmm. At the minimum, the intelligent control wall must have a sensor that measure the process temperature, means the line pressure also he will measure, upstream and downstream pressure, fluid flow rate, and all wall conditions, temp position, cylinder pressure, and positional characteristics. So you see here, it looks like it has one controller for the wall, because these data is required for wall upstream pressure, temperature, flow rate, and related to the wall mechanical parts. So it needs a powerful microprocessor to analyze these conditions. So definitely, as I told, this is a controller with uh, dedicated softwares for that. The program in the microcontroller must be capable of acting in a single loop controller, interlock device. That's all. So these are something about intelligent control systems. Applications of intelligent control systems. The original application of these control system was those processes that had a high labor cost, expensive process material, and very sophisticated control needs. So, because the walls are very costly, normal walls in the industry is more than 2 lakhs, 3 lakhs because of construction material. So, example of these includes offshore oil production platforms where the cost of stationing personnel is very high. Second area is the pharmaceutical plants where the chemicals are very valuable and maybe hazardous. Aerospace application where the process response times are measured in milliseconds. So these are very critical areas. There, these walls we can apply, and we are applying. As we have learned in actual application, these industries are very interested in the intelligent control wall systems. But the chemical process industries and textile industries have a control problems that are just daunting because of normally cost only. Mhm. In addition to the better control and lower installation costs, intelligent wall systems with the process sensors can be used to diagnose the process problems. Just a minute. For example, if you see here, looking to the relationship between the upstream pressure and the flow, an intelligent control wall can detect the pluggage or pump wear in the system degrades. It can detect the seat wear in the wall also. So you can see here the intelligent wall in hello,
Hello, yes,
hello.
sir. Yes, sir.
Uh, uh, can I continue now? Yeah.
Yes, sir. We
Uh,
will continue by tomorrow for BE lecture.
okay, okay, okay,
Is it
okay,
finished?
okay,
The
okay.
control wall is finished now.
Mostly there are few slides left, but these are advanced. I mean, like I want to just 2 3 slides more. Let me finish. Huh? Sure.
Okay, okay.
See here wall stem. This is the linkage I was talking. This goes to the positioner. This link. This is a stem which is moving proportionally. So see here wall stem, and there are a link is there with the magnetic sensors are there. So you will get the signal what position wall is there. So no mechanical coupling. See normally what was happening, due to the mechanical coupling, wall get sometimes due to corrosion and all was not giving a proper performance. But now the technology has come with the magnetic sensors. So no mechanical movement with the positioner. And so that is what no mechanical coupling, less sensitive to vibration, no linkage, less stresses, and less risk of injury. So this is about walls. This as I told. Mhm. ठीक है, that's all madam, huh?
Yes,
This is
sir.
related to calibration
Okay, okay.
further
So thank you
about
very much, sir,
so
for
next
delivering nice lecture to third year students.
first of all, I'm sorry for initial technological problem with me to start
No,
the
sir, no, sir.
session.
It's
Sorry
okay.
for that.
So you
Uh,
have given a very nice talk on the transmitters and control wall. I think it will add good values in their knowledge. Okay. So
uh,
thank you very much, sir.
thank you.
Tomorrow we will meet
Thank
for
you.
the B students. Okay, at
Thank you.
11 a.m.
Okay. Oh,
Okay, sir.
thank you.
Thank you.
Thank you. Thank you. All the best.